Hi, hi team. My name is T. Manoj Kumar. Basically, I am from Andhra Pradesh. Currently, I am working for HP. Actually, this is a small demo video about the networking stuff, which is helpful for all us. Overall, I am having 8 years of experience in the networking industry with both lab administration, network administration, and although with along with protocol testing and network testing in the IT industry. Today we are going to learn what is meant by networking and how the various objects we will use and what are the various things we are going to learn and how it will be useful for us and what is the current situation of for the networking industry in today's life for every person. Yeah, then we are going to drop into the networking demo. Let me share my screen. Let me share my PPT section. Just a second. Yeah. What is meant by networking? As you know, today everything is networking. Everything is without network, we won't be there. That means every object in the world is connected with each other via network. That much powerful our network is. So without networking, the world is not there. Every device is connected with each other with the help of networking. Networking means, in simple words, connecting end to end. Either whatever mission you take, whatever it you can take it, connecting end to end. That is the high level of what is meant by networking. Okay. Then we are having various companies. Each company has different tracks of their networking own courses. Yeah, among those, the popular companies are Cisco and Juniper. Now, I'm having experience in both enterprise routing and switching and service provider routing and switching. We are having different tracks of networking. Like just go to the another session slide. In Cisco, we are having the various levels of tracks like CCNA, CCNP, and CCIE. And Juniper has JNCIA, JNCIS, JNCIP, and JNCIE. These are various stages of classes where we will learn deeply into the networking, which is useful for us and to grow our career. Here, if you see right, here I only mentioned high level of CCNA, CCNP, and CCIE. These are common for all tracks. What I mean to say is, for example, notepad I am taking here. Enterprise, we are having different of branches. Enterprise routing and switching, and we have service provider routing and switching, and data center routing and switching, and we have security branch security, and we have DevOps also. Like this, these are the various branches, and for each branch there will be various levels like associate level, professional level, and expert level. If you see here, the Juniper has 4 levels, and Cisco also has 4 levels. First one we can ignore, and we can directly we can take to the CCNA associate level training, and we can take certification of that. The prices of this certification will vary along this many years. When I take the certification at that time, the cost of CCNA is around 20,000 price. Now, I'm not sure what is the exact price currently. These are the very valuable certifications, and not only in India, this is worldwide valuable. That means wherever you go, and these certifications are valid, and each certificate is valid for 3 years. Within the 3 years, you have to take another certification to get first certificate to extend the validity period. This is for the both Cisco and Juniper. This is the same process both guys will follow. When, yeah, these are the high levels of what is certifications and which we are interested. As I told here, you can take any of these branches, enterprise routing and switching, and suddenly if you go directly, if there is no networking experience, if you go for security and DevOps or data center and enterprise routing and data center routing and switching, right, it will be very difficult without learning some basic stuff. So what my suggestion is, take either of the course, enterprise routing and switching or service provider routing and switching. Then you can take any of these branches so that it will be helpful for you. I am from enterprise routing and switching and service provider routing and switching background. I'm having some familiar with data center also. This is the various tracks and certifications nowadays every person and your company is following to gain the knowledge at various levels, which will be helpful for the company and their own career. Now, when we come into what are the main products in our networking we will use? That means, for example, today, right, wireless is very powerful. That means everywhere, from our gadgets to everywhere, mobiles and tablets, we will use 802.8.3.11 is a standard IEEE standard. By using that, we will connect the devices by using wireless standards. Now, when it comes to physical, right, there are various products we will use in networking, like cables, hubs, bridges, switches, routers, networking central, and various optics. When here, just when come to the cables, right, to connect the devices, to connect the two devices, we will use cables. Like we are having different types of cables. For example, if I take two routers, here between these two routers, as those are same products, we will use crossover cables. And these are the Ethernet cables. And this, when it comes to the cables, right, we are having different standards which was given by IEEE, Cat 1, Cat 2, Cat 3, Cat 4, Cat 5, Cat 5e, Cat 6 and Cat 6a and Cat 7, like that. Out of that, right, Cat 1 is the oldest cable where we will use old telephony standards. And currently, right now, we are using Cat cable of 5, 6 and 7 cables, which supports up to the 1 Gbps to 10 Gbps speed. These are the copper cables, and these are the cables look like. These are the cables, how it will looks. These are the cables where we will use in our old telephony wires and current standards. When now between the similar products, right, we will use the crossover cables, and we will use a rollover cable for console connections, and we will use straight cable between the different types of boxes like router and switches. And we will be having largely fiber cables, which are those are the high speed and long distance cables. These are the various types of cables we will use in today's networking. And what is known by hub? Hub is nothing but a small switch. Earlier, long days back, we will use this hub where two devices, multiple devices can connect to this hub. Only one device can able to communicate at a time. If two devices are communicated at a time, but there will be collision. Collision means there is a collision and no data transfer will happen. So we will use at those times CSMA CD, which is called carrier sense multiple access and collision detection. CSME, see this IEEE standard we will use. That means two devices can't send the data at the same time. Only one device can send the data. Okay. In those days, that we are following that standard, and later bridges came. Bridges means similar type of switches, but less number of ports it has. Switches has lot number of ports like 60, 40, many of the ports like hundreds of ports switches has, but bridges no, very less number of ports like 2 or 3 ports it has. In bridges, we can overcome that kind of issues, that collision detections like that. In hubs, right, we are having one example we can take like walkie-talkie. Only one person can talk at the time. At the same time, second person, if they talk, there is a collision. This is one example. These are the switches. Now today's we will use within the LAN hubs. We know got to know and what is in the bridges. This similar kind of switches in old days, less number having, which is having less number of ports. And when what is meant routers? Routers means when we are coming out of the LAN, then we will use routers. Today's the routers plays a major role in the world. Without routers, nothing is possible. That means within the LAN, with the help of switches, you can transfer the data. But between the LANs in different areas, we need routers. Then what is maybe network central? This is one application. Through this, we can push the configuration to the devices as a hub, just without CLI. With the help of network central, we can push the data configuration to the devices by using API calls like that. And lastly, what is meant by optics? Optics are nothing but where we will use fiber cables. If you come here, if you type optics, 10G optics, we are having various optic levels of. If you see here, these are the various optics we will use today's standards. This first one you are seeing, right? This is called copper optic. That means you will use copper cable. Okay, and the copper cable is here like this. Cat5 cable. If you type here Cat5 cable, right? You can see here this one. The end of the cable, no, the tip will be like this. This will be inserted in one end of the optic, and another end will be we have inserted another end of the optic. These are the cat cables which will support less speed. And this here you are seeing, right? This one, this is called SFP, small factor pluggable. These are the fiber optics which will be helpful where the data transfer is happening with the help of light. The speed of the light is very fast, right? So here the fiber cables we will use for this kind of optics. Fiber optics. You see here, these are the types of fiber optics cables where you will plug into those optics and the data transfer will be very high speed. The optics are various ranges are there. One is 10 gig cable, 10 gig optics, and 1 gig and 100 gig and 40 gig quad SFP. And each optic can be used in multiple ways. That means one optic can be split into 4 cables. That means 140 gig optic can be split with the help of a 40 split cable into 10 gig cables split by using split cable. If you see here, split cable, it will be one end will be 40 gig and another end will be another end we will use for one end will be 40 gig optic and another end will be 4 cables which will use which is used to connect to the 10 gig optics on other side. here you can see, right? This is like this, it will be. This is the cables, like it will be. One side will be connected to the 40 gig optic, and the side you can connect to 14 gig optics. These are the major products which we will use in our daily networking. Okay. Now, when this is the higher level of devices and what are the various objects we will use in our networking. Okay, higher level. When come to the communication, right? How two devices will be able to communicate? We are following IEEE standards like OSI reference model and TCP IP stack, which is the current model. OSI is the oldest model, and TCP IP stack is the latest model, which is precedence to that. Both has the same structure. That means, for example, two PCs, if you want to communicate, how the data will go from each level to each level, and how the data is transferred to another PC. Those stuff is based on the OSI reference model and TCP IP stack. In OSI reference model, mainly we have different layers called application layer, presentation layer, session layer, transport layer, and network layer, and data link layer, and lastly link layer, which is useful for data transfer. Now, this is OSI reference model is very big concept where at each level we will go to different steps and what will happen at each level. Okay. In that highly, I picked three layers. Okay, one is transport layer. In transport layer, when the data, if you are, for example, we are having two PCs. In one PC, there is a client. In another PC, it's called server. Two applications are running between those two. If the data is coming from the top level, application layer level, when it comes to the transport layer, initially, a TCP handshake has to form a transport layer. Once the session is formed, then what we will do means we will convert the data in the form of segments, small blocks. Then we will give that segment to the next layer, which is called network layer. There, by using which destination we have to send this data, we'll encapsulate this segment inside the packets. Next layer, if you come to the layer 2 layer, which is called data link layer, there we will take all this packet, we will put encapsulate into the frames. Frame contains which is what is the source MAC and what is the destination MAC, this kind of information. Once the packet is encapsulated inside the frame, then we will send this frame in the form of signals to the other end PC. The other end PC, what it will do means, again it will take that signals in the form of zeros and ones, the bits, it will be converted into the frames. And from the frame, we will pull the packet, and from the packet, we will pull the segment, and from the segment, we will pull the data, and we will send to the application layer, which is running on the server side. This is the high level flow of the packet from source to destination by using OSI reference model and TCP IP stack. Now, when it comes to packet flow, as I told just now, if the two devices want to communicate each other, this is one PC which is connected to one switch, which is connected to a router. This router is connected to one switch, and this is connected to one PC. Okay. Now, for example, this device has here, firstly, in our networking rate, main objects are, as I told, MAC addresses. MAC addresses and IP addresses, these two will be playing every day in our life. MAC addresses are nothing but hardware addresses. For each device, it will be assigned. MAC address contains 48-bit MAC address, First 24 bits will be given by a national authority, and next 24 bits and first 24 bits will be given by to the organization, which is common for all the devices. Next 24 bits will be varying. And when come to IP address, it's a 32-bit address which has various classes of the IP address: class A, class B, class C, and class D, and class E, up to 255 IP range. This is the range starting from 1 to 255. From 1 to 127, 1 to 126 is first class A network, and class B is 128 to 191, and 192 to 193 is class C, and class 4 is useful for multicast purposes, and class 5 is useful for research and development purposes we will use nowadays. These IP addresses and subnetting, and it's a very huge concept. That means you will take one network and you will break down that network into multiple pieces to save the IP addresses, because IPv4 has very less number of addresses. Because of that, we will use most of the time subnetting in our networking concept, which is the first topic, where we will use where we subnet the network and will assign to various devices because of lack of addresses. And in IPv6, we are having billions of addresses. There also we will use subnetting, but the major concept why the subnetting came, right, that is the major lack of addresses today network. This is the first topic in our networking, where we'll cover the subnetting and what is classless and what is classful, and VLSM, everything will cover, okay? And as I told here, how the two devices will communicate. For example, both devices are in the same network. If two devices are in the same network, then we don't need these routers. Two devices can connect to the same switch within the LAN. We not require any router. Within the LAN, two devices are in the same IP network, so they can communicate each other. If the device is in different LAN, for example, this device is in X network, and this is device in Y network, at that time, we need routers. That means to reach this PC on the right side, we have to hand over our packet to the default gateway router. This router should know how to reach this network. We can configure a static route on this router to reach this network. Likewise, on this router, we can use static route to reach X network, okay? By using static routing, or we can use any routing protocol, we can run the end of the networks between these two routers, so that these routers are known who is this X and who is this Y. So once the packet comes to this router, as this guy knows how to reach this Y, because by using one of the routing protocol, then he will hand over that packet to this router, and then this packet will hand over that one to this Y. This is the high level flow. When it come to deeply, right, at each frame, what is happening and what is changing at each layer, MAC addresses are changing or destination IP addresses are changing, we will later come to know, okay? This is the high level of packet flow between the two devices, okay? Now, when come to switching part, right, what is LAN? For example, LAN is nothing but we are 100 people sitting into the same room. At that time, whoever called, other person will respond. Local area network within the room, within the switch, we can talk each other. That is called LAN. If you want to go away to the other class, then we need one router. There we have to configure gateway, that part, okay? Now, within the LAN, right? Earlier when we discussed what are the products we will use here in Hub, we are discussing only one person can send the data to other person, other people has to listen while other person is sending data. When we come to here switches, right? The same behavior here also. only here only one broadcast domain by default. Okay. To overcome that issue, what we can do means here here one collision, that means each port has one collision domain. That means for here by default in hubs only one collision domain and only one broadcast domain. But in switches, right, each port has one collision domain and each only one switch has one broadcast domain by default. That means here the collision issue we can overcome, but we have only one broadcast domain. All devices are fall into the single VLAN, one VLAN. That is by default in Cisco VLAN 1 is the default VLAN. We can break that broadcast domain into multiple broadcast domains by creating the various number of VLANs. Up to 4094 VLANs we have. We can create different broadcast domains and we can put each of the port into those so that one people sitting in one broadcast domain can't talk to other broadcast domain. If you want to talk, then it's like a separate LAN. So we need one router at the middle. So this is called LAN and collision domain, broadcast domain. And what are VLANs? VLANs are nothing but we are dividing the network, we are dividing the switch into multiple broadcast domains by creating the VLANs. In those VLANs, we will configure what is meant by access port. That means by default, access port belongs to only one VLAN. That means when the traffic is coming from the local host to this port, it can send the data to the other switch by using trunk port with which VLAN the data has to be sent by using tagging. We are having a tagging mechanism, 802.1q.1 tagging mechanism, which we will use between the switches if they want to span between the switches, the traffic. These are, we will go deeply at each classes when we come to the VLAN port, access port, switch, trunk port, everything. When it comes to port security, right, by default, a switch doesn't have any port security capability. That means any person can jack their cable into that switch and they can use. And many devices, a single switch port can support as many of the links you can remove and connect it like that. To overcome that issues, we have many mechanisms like we have to sticky mechanism. That means only for one MAC up to we can define how many MACs it has to learn. Only those MACs has to be, or we can define only MACs has to be learned from that switch port. Like these things we can learn in port security. And when you come to STP, RSTP, and VSTP, what are these? These are the looping mechanisms where we will use in switches for redundancy purpose. One second. For example, if two switches are there, we have one router, one host, which is a PC, which is connected to these two switches. Why we are connecting that to two switches? Say, for redundancy purpose. For example, this PC is communicating outside network by using this switch. When the link goes down, whole communication is stopped. To overcome that issue, our PC might be connected to these two switches for redundancy purpose. When we are using redundancy purpose like this, if you follow this same topology for unknown bump traffic, broadcast and unknown unicast and multicast traffics, the frame is looped over here and it will cause broadcast storms and the whole system will be going to downstate. To overcome those issues, right, we will use spanning tree protocol. When you use spanning tree protocol, right, here one link will be blocked state so that there is no loop at all. So this is the one IEEE 802.1W, 802.1D and 802.1W standards we will use for this mechanism which will stop the looping mechanisms. Here I mentioned STP and RSTP. These two are legacy protocols. Same behavior they will follow, but the time for converting, for example, if the section is break here, immediately this port, which is in blocking state, has to be converted to the forwarding state. So in STP, it may take some time around 50 seconds, but in RSTP, the conversion is very fast. Both are legacy purposes, but these are not redundant, that means not reliable. So we will go for VSTP and MSTP. That means even though if you have thousands of VLANs, only one switch will elect as a root bridge and remaining switch as remaining backup switches. Okay. In VSTP and MSTP, right? If you have 1000 VLANs, for each VLAN, you can configure one switch as a root bridge so that we having reliability and redundancy also by using VSTP and MSTP. Here per VLAN, we will elect one root bridge. In MSTP, per region, we will elect one root bridge. These are the various concepts for looping mechanisms we will use in switching, where we will go in depth and we'll play over here. And when come to the private VLANs, these are the advanced concept where private VLANs, right? Here multiple, I said one switch, we can configure multiple VLANs like this, and each VLAN is nothing but one broadcast domain. Even though, for example, if we want the two people who are sitting in same VLAN not to communicate each other, then we will go for private VLANs. In private VLANs, we have three types of VLANs. One is isolated VLAN and community VLANs and promise, and we are having one promise case port. Okay. Here, isolated VLANs can't there for this is the high level. In single VLAN, two people don't want to communicate each other, then we will go for private VLAN. This is advanced concept, but I will be clear and will play over here. I can break the how we can play here. And finally, we have various advanced concept where multiple vendors we will use virtual chassis like that. That means, for example, if you have 5 switches like this, to manage these three switches, it's difficult to manage, right? So at sometimes each switch will play as one line card. At that time, we will connect back-to-back connections like this. This is the virtual chassis concept. At that time, these three switches will act as a one device. So managing is easy, and it will be we'll use this fabric in data centers mainly, virtual chassis fabrics concepts mainly. This is the high level view, and we will play over here also. And now when coming to the next routing concept is called gateway. As I told, we are all in one room. We don't need any gateway and we don't need any router. When you are going outside of the room, then we need gateway. Gateway is nothing but our door. That means to reach outside the network, we have to reach out to the gateway first. Then we can reach out of the network. This is the high level view. Okay. Next, when we come to routing protocols, we have many routing protocols we will use. By default, the simplest way between the two routes between configuration is here, as I told in initial figure, to reach this Y network from this A router. This is B router. If you take to reach this Y network, you can use the static routing. Simply just to reach this Y network, use the next hop as this one. This is a static routing. Likewise, we have various routing protocols. RIP is the routing information protocol. This is the very old routing protocol where you will use in very small enterprises. Okay. And this EAGR, Enhanced Intergateway Routing Protocol, it is Cisco proprietary protocol. Now it became as a open standard, where earlier it is Cisco proprietary, now it is not. This is somewhat advanced, and currently this is the main protocol Cisco people will be using. And OSPF is there, right? This is open source protocol, which is very powerful, and where many vendors are using this protocol nowadays. Here, each protocol has various versions like RIP version 1, 2, and 3, and AGP version 1, version 2, OSPF version 2, and version 3. And BGP is a wonderful, powerful protocol where we will use in service provider networks, and where you are having multi-home internet connections. There we will use this BGP protocol. BGP protocol is very powerful, and it's a game changer in networking industry. Every service provider will use this BGP protocol nowadays. Why? Because it has various attributes to control the traffic coming in, going out. It has various attributes by using like next hop, local preference. We will go in depth. Don't fear. This we can use this BGP protocol within the enterprise and between the various service providers. And this BGP protocol has, as I told, various attributes. By using this BGP protocol, it has another concept, MPBGP, where we will use in the MPLS technologies for carrying the VRF routes between the PE devices, provider edge devices. Okay. And finally, MPLS, multi-protocol labeled switching. This is another wonderful protocol where we will use in today's networks, mostly in service provider routing and switching. As I told initially, we are having different tracks like enterprise routing and switching and service provider routing and switching. This MPLS and L2 VPN, L3 VPN, and layer 2 circuits, cross connects, everything we will cover in service provider routing and switching track. This is one of the concepts where we will use this MPLS over there. Simply, I'm saying, for example, if you are using OSP, why we need MPLS instead of OSPF protocol? If someone asks you OSPF protocol, if, for example, if you have 10,000 routes in your router, if there is a route at the middle of that, for processing that route lookup, everything, it may take some time, more time, but that can overcome today's technology with latest ASIC processes. But the why we are using MPLS is traffic engineering. Traffic engineering means if you have two routes between the PE routers, one is top and one is bottom in the diamond topology, like this. For example, if you are having this, consider this one as one PE router and this is another PE router. If you are having two parts between bottom and top, right, always by default, router choose the path to reach this P lowest cost. If the top has lowest cost, we will choose the top path as to reach the destination. We won't select on the bottom one. Why? Because that is the nature of this interior gateway protocols. That means within the enterprise, we will use these protocols, OSPF, PHRP, IGP, static. Exterior protocols are nothing but BGP, MPLS, okay? But by using MPLS, right, to reach this network, if we can use bottom path also, by adding additional path attributes, arbitrary paths, we can follow this MPLS by using bottom path. Here, MPLS plays a major role. Here, we will carry each route with one label by using various label distribution protocols called label LDP and RSVP. Those are the main two protocols. Although LDP is used for reducing the overhead on the router, but we will use RSVP for traffic engineering. That is the main purpose of RSVP. These are the high level view, okay? We'll cover these things in service provider. And when we come to the data center technologies, right, as I told, in data centers, we will use EVPN technologies, okay, VXLAN, EVPN technologies. where if you for example, if you have a VMware concept, if you are very familiar with the VMware concept, if you have a VM in one of the EXXi hypervisor, which is connected to the router, and this router is connected to the another router, which is connected to the another VM. For example, why we need VXLAN technology? Why we use EVPN technology? The main purpose is sometimes the end VMs in applications want to use a layer 3 network on the core side. This is the core MPLS core here we will use. If the end applications not required any layer 3 technology IP, if they want layer 2 here, the overhead will be high. Why? Because end-to-end is layer 2, so we have to maintain spanning tree protocols, everything. So to overcome that issue, we will go for IP over here. And also we are having up to 4094 VLANs only. Here in VXLAN concepts, right, we are having one field called, one attribute called virtual network identifier, which is 2 power of 16 VNIs we can use between the data centers by using VXLAN technology. EVPN as a signaling protocol. EVPN is signaling protocol. As I told, MPBGP will carry the data routes from this PE between the PEs. Okay, this is the major EVPN VXLAN technology we will use in data centers by taking few routers as a spine and few routers as a leaf technology. And bit for signaling mechanism, we will use multicast or we will use MPBGP. This is the high level overview of EVPN VXLAN, which where we will use in the data centers between the applications. As I told here, initial tracks, right? This data center also one branch. This is also we have one branch like associate level, professional level, and expert level. These are the various things we will cover in networking portfolio. And when come to Python automation with Linux, right? For now we are familiar with what is network and how to configure and what are the various debugging steps we will use for overcoming issues, everything. For example, if we have 100 routers in our lab, to configure each router, it may take more time. We need multiple employees to configure. By using Python automation with the help of Linux basic stuff, we will import some of the modules, Python modules like telnet lib and telnet libraries and Paramiko libraries. We will use these libraries and we will single shot. We can configure all the 100 routers by using various multi-threading concepts in Python. All the routers we can configure at the single time. Here we can, yeah, this stuff also will cover in, which is nowadays only networking is not sufficient. We have to know additional technologies like Python, basic automation, and Linux concepts, and what are the various commands we will use for transferring data from here and there. And we have to know the VMware stuff, what is VMware and why we need to deploy various VMs, and what is meant by EXXi hypervisors, what is vSwitch. Everything we can cover in this section. This is the various concepts where we will cover in our networking stuff. Yeah, thank you very much.